This is part 2 of our video on geometric series. So in the last part we took a look at the formula for geometric series and we did a really basic example. And now we're going to continue on with our last 2 examples. So this question says, determine the first term in the sequence where the common ratio is 5 and the sum of the first 8 terms is 216. So I see some conflicting things here. I see it says sequence and I also see that it says sum. So because it says sum, that tells me that this is a series question, right? So it is a sequence, but it's being added together, which makes it a series. The other thing I need to do is figure out whether this is arithmetic or geometric. And because it says common ratio, that to me is a flag that this is going to be geometric. If it was arithmetic, it would have a common difference, but if it's geometric, it should have a common ratio. So what I'm going to do here is I'm adding the terms together, so that's a series, and it's geometric because there's a common ratio. So I'm going to use my geometric series formula, which is Sn equals A times r to the power of n, take away 1. Now that take away 1 is not in the exponent, and then divided by r take away 1. I'm going to zoom in a little here. And then I'm going to list my S, A, R, and N. And see what information I can pull out of the question. So it does say that we want to find the first term. The first term in this case will be A, so that is likely what I'm looking for. And it says the common ratio is 5. The common ratio would be our letter R. Okay, we want to find the sum of the first, it's hidden over there, 8 terms. So if there are 8 terms, that means n is going to be 8. And then it says that the sum of the terms is the 1,074,216. So that's actually my S. So we're going to take all of those numbers and substitute them into the formula and then solve. So we have 1,074,216. That's my S. I do not know what A is. R is 5 to the power of 8. And then that take away 1 is not a part of the exponent. And then in the denominator, it's R again. So 5 take away 1. So first thing I'm going to do is the same thing I did in the last question. I'm actually going to work this part out on my own. It's pretty easy. 5 take away 1 is 4. So I'm just going to say that that's 4. And then I notice that I want to solve for A. So somehow I'm going to have to move all of these things over to the other side. So I am going to start with the 4. And what I'm going to do is multiply both sides by 4. So if I take 1,074,216 and I multiply it by 4, I get another very nice large number here. So I get 4,296,864. Now, at this point, I have a choice. I could work out 5 to the power of 8 minus 1, but sometimes that number is going to be a little bit too big, so it's always worth checking out to see. And to me, that's okay. It's not in scientific notation, so it's not being rounded. If it was in scientific notation, I probably would just leave it and divide by the whole thing, but I'm going to work this out since it worked out fairly nicely. This is 390,624. And then to solve for A, all I need to do is divide both sides by 390,624. So I've got 4,296,864 divided by 390,624. I end up with 11, which tells me that the first term is 11. So for that, I'm actually going to write a little sentence. I'm going to say the first term is 11. Okay, we have one more question here. It says determine the sum of the terms in the sequence 2048, 1024, 512, and then all the way down to 1. So the first thing we should do is try to figure out whether we think this is arithmetic or geometric. So I notice that the terms are getting smaller. So here, 2048, 1024, I'd be subtracting 1024, but I'm not subtracting 1024 to get from here to here. So I know this is not arithmetic. So what I can do for geometric, if I want to check for that, is I always take the second term and divide it by the first term. So 1024 divided by 2048, and I get 0.5. So here we are multiplying by 0.5, and then I can check, and that actually works out for the next term as well. Now if you ended up with a decimal that was not nice and exact like this one, 0.5, doesn't have anything I have to round, I would like you to use the fraction. So to find the fraction, you can actually then go the other way. So you can do 2048 divided by 1024, and I get a 2. So this would actually be times 1 over 2 if you wanted to do it as a fraction. But since it did work out to be a number I did not have to round, I am okay with you using the decimal. So this tells me it is definitely geometric. Now, sequence or series, a sequence is just going to be a list, and I do see the word sequence, but I also see the word sum. So since it says that we're looking for the sum, that means we have to add together all the terms in the sequence. This is actually a series question. So for a geometric series, that's the new formula that we just learned. So I have Sn equals A times R to the power of n, take away 1, not in the exponent, divided by n, R, take away 1. So I'm going to list S, A, R, N. Okay, do I know the sum? No. That is actually what I want to find. Do I know the first term? Yes, it is 2048. Do I know my R? Yes, I can either use 0.5 or we could be fancy and we could use 1/2. I think in this case, I'm going to go with 0.5. Now, N, do I know how many terms there are? Unfortunately, the answer to that is no. I do not know how many terms there are. But I can't have 2 unknowns. I can only have 1. So I know that what I want to find is the sum, which means there has to be some way for me to figure out how many terms there are. And the way we figure out how many terms there are is we use our last term, which is the 1. The last term, that is always Tn. So what I can do is use my geometric sequence formula to figure out which term that term is, and then that'll tell me how many numbers there are, and then I can use that to help me figure out this. So this is actually a 2 calculation kind of question. So we're just going to slide over here, and we're going to figure out what term this is using our term formula for geometric sequences. So that one is Tn equals A times R to the power of n take away 1. Now that one is in the exponent. So I know Tn in this case is 1, and I can actually list my values if that helps. So in this case, my term is 1. The first term is still 2048. The R is still 0.5. And then what's missing here is the n. So Tn, which is 1, equals A, so 2048 times 0.5 to the n take away 1. Now, since I want to solve for n, I either need to multiply these two numbers together, or I need to take something to the other side. Can I multiply these two numbers together? The answer there is no, I can't. Why not? Order of operations. Order of operations, or BEDMAS, says that you have to do your exponent first and then multiply. So I can't touch that 0.5 until I've worked its exponent, and since I don't even know what the exponent is, I can't multiply. So what we're going to do is take that 2048 to the other side. So if I divide 1 by 2048, I get a decimal that I am likely going to have to round, and that does not make me very happy. So what I'm going to do is just leave this as 1 over 2048 is 0.5 to the n take away 1. Now, I think this question would go far better if instead of using the 0.5, I actually used the fraction equivalent, which would be the 1/2. So I'm going to write that in as 1/2 to the n minus 1. The reason I put the brackets in is so that I know the exponent is for the 1 and the 2. So if I have 1/2 on this side and I have 1 over 2048 on this side, what I want to do is try to write them as powers of the same base. So that base is going to be 1/2, and I want to try to figure out what this is as a power of 1/2. So instead of looking at the ones, I tend to just focus on the 2 and the 2048, because 1 to any power is 1, and it always works out. So you can do some guess and check on your calculator. You can use your power sheet. Usually I use the power sheet. I'm feeling a little guess and check today. I actually think this might be 2 to the power of 10. Nope, that was close though. That's going to be 2 to the power of 11. Okay, so 2 to the power of 11 is 2048. So this is 1/2 to the power of 11 is 1/2 to the n take away 1. So since the bases are the same, the exponents are going to be equal. So 11 is going to equal n take away 1. I add 1 to the other side to get that there are 12 terms. So that was a lot of work just to figure out how many terms there were. Why did I want to know how many terms there were? I wanted to know how many terms there were so that I could actually do my sum calculation. So now that I know that there were 12 terms, I can put 12 in for my n, and then I can calculate my actual answer here. So Sn, you can leave it as Sn, you could leave it as an S, I'd be okay with that, or we could write S12, doesn't matter, it's just notation, is A 2048 times R 0.5. You could use that 1/2 if you want, it doesn't matter, to the power of 12, take away 1, not in the exponent. It gets confusing between the two formulas, but it's not in the exponent. And then R again is 0.5, take away 1. Now I do like to do all of this in one step on my calculator, but first thing I'm going to do, and I will always do, is I'm going to work out that denominator. So in the denominator, 0.5 take away 1 is going to be negative 0.5. And then I'm going to calculate. Okay, so 2048 times bracket 0.5, 0.5 to the power of 12, take away 1, close bracket, divided by negative 0.5 equals 4,095. So the sum of the first 12 terms is 4,095. So the sum of the terms in that sequence is 4,095. Oops. Don't need a decimal place there.